Okay, so welcome class again for new a piece of life lesson vlog of Ma'am Hannah Jane Silcumba Costello, licensed professional teacher. Chemical bonds, bonds of order. Chapter 2 defines a chemical bond as the sharing or transfer of electrons between the outer surface clouds of atoms. And figure 2.2 depicts a CC or carbon-to-carbon bond. The carbon atom nuclei were represented as two gumballs, each surrounded by a sticky electron cloud of cotton candy. The bond resulted when the clouds were smashed together then slightly pulled apart. Bonds in order. Picture in your mind groups of 3 or more atoms held together by chemical bonds. So the chemical bonds are, for example, hydrogen and sodium chloride. So 2 atoms of hydrogen and 1 atom of oxygen, each equals to water. And then NaCl, so one atom of sodium and 1 atom of chloride. 2 atoms of chlorine, or okay, so sodium chloride. So do you see triangles or other simple geometric patterns in hindi pala sa sodium chloride pala is 1 atom of sodium and 1 atom of chlorine. So sodium chloride lang yan. When we say sodium dichloride, di means 2. It's a prefix, means 2. So magiging 2 atoms of chlorine, di ba? Just like, di ba, carbon monoxide, mono means 1. Carbon dioxide, di means 2. In a functional sense, chemical bonds are builders of order. They are builders of order or pattern at the chemical level of biological organization. Consider 2 specific examples: a water, hydrogen and oxygen molecule, and a sodium chloride NaCl crystal. So this is what is important. The water molecule is shaped like a triangle or V, with the O oxygen atom at the tip or apex sa taas niya. And then sa vertex ng pinakatuktok niya. Hydrogen, H atom is attached on each side by a covalent bond, one that involves the sharing of outermost electrons. Electrons are negatively charged particles between atoms. Since the larger oxygen atom draws each of the electrons from the hydrogen atoms into a closer orbit around itself, positive and negative poles are created. The O end is the negative pole having an excess of 2 negatively charged electrons, while the catch H and makes up a positive pole. The H ends or hydrogen ends on the catch bond create a positively charged pole because their electron has been unequally shared with the oxygen. In effect, the oxygen atom is an electron hog. It still leaves each electron-robbed hydrogen atom with its positively charged proton, however. Now let us consider the salt crystal. Figure 4.2, numerous sodium and chlorine atoms combine with one another to form a beautiful cube-shaped solid. This precise or correct or accurate geometric pattern is seen in common table salt. Think of this when you are cooking your salted pretzels or french fries. Each face of the salt cube is a square with alternating sodium and chlorine ions as its corners. So an ion is an atom that has either a net excess or deficiency or outermost electrons such that it is electrically charged. The sodium ion, for instance, is symbolized as sodium because it has a deficiency of 1 electron. Where did this electron go? It was transferred from the outer cloud of the sodium atom to the cloud of the chlorine atom. The result is an ionic bond, a bond that results from the transfer of 1 or more electrons between atoms. And since the chlorine atom picks up the extra electron being transferred from sodium, it becomes a chloride ion, C1. Having an overall negatively charge. Thus, we see that there are 2 main types of chemical bonds: covalent bonds and ionic bonds. Covalent bonds result from the sharing either equal or unequal of the outermost electrons between atoms, while ionic bonds arise from the complete transfer of 1 or more outermost electrons between atoms. Thank you for listening.